Hey, what's up guys, my name is Achona. Welcome back to the Code Review series, Holiday Edition. I'm currently in Germany, so we'll see how this goes. In this special Holiday Edition of the Code Review series, I'm gonna take a look at my own code. So recently I made a video, networking in C++, I'll have it linked up there so you can check it out. And for that video, I made an application in C++ using my Walnut framework called Walnut Chat. It's like an instant messaging kind of chat application, you know, kind of like the hello world for networking. So I didn't quite have enough time to talk about the code and look at it kind of deeply in the networking in C++ video, so I thought I'd just do a code review so we can take a look at it. I'll show you guys how it works. Obviously a code review traditionally is someone else looking at someone else's code. So this is not standard, but I have done it before. I've done it for Hazel. I'll have the Hazel code review linked up there. So for these kind of auto code reviews, I generally go through it and kind of talk about the design decisions I've made, why I've written the code a certain way, just explain how it works, and also try and criticize it because I never claim that any code that I've written is perfect. There's always room for improvement, so that's what we're going to talk about today. So the link to this Walnut chat repository will be in the description below, of course. It's completely open source, you can download it. There's actually a release over here, which you can take a look at. So if you just wanna kind of run the client, connect to the server, which is chat.thechannel.com, you can do that as long as the server is running and no one's crashed it yet. Otherwise, if you want the source code, just do a recursive clone of this repository and that will take you to this. This is what it looks like. Now, all of my repositories, I say this a lot when I kind of, criticize other people's setups for their kind of projects. But generally with all of my projects, one of the top requirements is it has to be easy to just build and run. So let me demonstrate what something like that might look like. Once we've cloned the repository, this is what the root of the repository looks like. I just go into scripts and you can see there's a setup.bat for Windows and a setup.sh for Linux, because this does in fact support Linux in kind of a headless configuration, which we'll talk about later in this video. So if I just double click on setup.bat, that's all I have to do. You can see it will run pre-make. It'll generate all of the Visual Studio 2022 solutions and projects. So there are actually two solutions, one for just Walnut Chat, which is like the GUI one, and then Walnut Chat Headless as well. Once I've done that, I can just double click on this. And once that opens, I can either hit F5 or just press this local Windows debugger up here to compile everything and run it. And specifically App Client, as you can see, is the default startup project. So if I wanted to run the app server, instead I could, set it as a startup project or just run it kind of through this. So this is it building. That's it, it's running. That's all you have to do. And then you can type in your name. You can pick a color, go with orange, and then chat.thechannel.com is the kind of default server, but you can enter any IP address, any kind of host name, along with like a port. So feel free to host the server yourself if you want, and then hit connect. And there we go. And you can see we can scroll up, see the message history. And yeah, that's, hello. No one else currently online because I actually just had to restart the server, it crashed. All right, sweet. So now let's take a look at the code and I'll talk a bit about how this project is organized in the first place. So I feel like really the architecture of the project starts with just looking at the root repository. We have several different projects, which you can also see here in Visual Studio, but we also have two different solutions. Walnut Chat is, as I mentioned, the kind of GUI applications. So aside from having this app client, we also have app server, which I can just quickly build and run here. And you can see that I've started a server now, but this is completely GUI. I can type here, hello. So the server also kind of has, the ability to talk. I can see what clients are connected here. If I wanted to, by the way, what I could do is start another instance of my app client. Let's just make sure we have the server running here as well. And then instead of, connecting to chat.thechannel.com, which I showed earlier, I can just do 127.0.0.1 for localhost, and then the port, which is 8192, hit connect, and you can see now that I have connected over here into this server that I am actually running here. And I can see the server's hello message, which I sent earlier, and I can type in some chat message, obviously, and you can see that it all appears with both the server running locally and the actual client as well. So this is the kind of GUI version of the server. Now there is also this headless solution. So if I open the headless solution, that lets us run the exact same server code, but instead of having a GUI, we can just run it as like a command line application, like a console application. Why would we want this? Well, if we're trying to run this on like a Linux server, for example, we're not gonna have any kind of GUI, and certainly not a Windows GUI. It's possible, obviously, for your server to have a GUI, and in that case, feel free to run the GUI version. But if you just have like a regular VPS, like a web server, then you're probably not going to have a GUI there. And besides, it'll probably be easier for you to just SSH in and just be able to run any kind of commands you want through a command line. So that's what this is for. You can see we have app server headless. So if we just run that, then you can see actually that it's running from the same working directory. So it's actually loaded the message history that we just made. We have the server saying hello, me saying hello, local server. We're now listening on port 8192. I can go back to the GUI version, the GUI client, run that, and then here I have the server, obviously. Here I have my GUI client with all my settings. Let's just go ahead and connect again. You can see that I'm here, and I can say hi, there it is, and hi from headless server, and there it is, right? So it's the exact same application, but just instead of having a UI, it's completely just command line. And I can also run some commands here, like kicking myself. Now, before we jump in and start taking a look at all this code, if computer science is something that you maybe are just beginning and you want some help, there's an excellent free way you can do that with a sponsor of today's video, Brilliant.org. Now, Brilliant.org is an amazing website filled with lots of courses on various STEM topics. They have some really nice kind of beginner computer science courses. They'll kind of hold your hand and guide you through like learning how to think like a programmer, which is obviously really important. But for those of us who might be a little bit past that, a little bit more advanced, I personally really love Brilliant.org for its math courses. And really from the beginning, like from this everyday math course, which again is kind of like that gentle introduction, hand-holding kind of, I have no idea what I'm doing, I'm scared, all the way up to like linear algebra and calculus. You know, we've been using that stuff in the ray tracing series, and Brilliant specifically makes learning this stuff like really fun. The fact that all of their courses are like super visual and interactive and engaging, like you can play with these widgets to see how numbers translate into visual things. They'll quiz you to make sure that you're paying attention and actually learning. All of that just makes it such a good experience and such an effective way to learn. Now, the best thing about Brilliant is that you can get started for free. They have a 30-day free trial that you can use to just check out the entire platform, go through their courses, see if you like them. And if they do work for you and you do go on to like them, then Brilliant have been nice enough to offer the first 200 people 20% off an annual membership. Just go to brilliant.org/thecherno and check it out for yourselves. Huge thank you, as always, to Brilliant for sponsoring this video. Okay, so now that we've covered like, you know, actually using this stuff and how it all comes together and how it all works, let's take a look at the kind of project architecture a little bit. So we have at the core of this Walnut. Walnut is an application framework that I made. We won't talk much about Walnut in this video, but I've got plenty of other videos on the channel about Walnut. Walnut Networking is an optional module for Walnut which provides networking functionality. And that's what I want to focus on in this video because it's probably the most important part of this chat app. App Common is a static library which contains the common functionality needed by App Server and App Client, which are our two executables that come out of this. So let's start by talking about the Walnut Networking project and API. Basically, I just wanted an easy way to spin up a server and a client and like handle the messaging between the two. And I guess technically more than two, because you can have as many clients as you want. And by easy, I just mean I wanted the API to be straightforward and simple and clean. Often what I like to do is boil everything down to like its most simple form, because I feel like at the end of the day, what we're trying to do here is not really that complicated. And to be clear, when I say not complicated, I'm not talking about like the back end kind of technical details. Those can be quite complicated, of course. I'm talking about like the kind of front end API. I always like to have a good kind of high level, clean, simple way of doing things, kind of like a scripting language would be for a game engine. The game engine itself can obviously be extremely complicated behind the scenes, but maybe I just want to like, I don't know, render my character or make him move somewhere, or I don't know, turn a light on. Like, I don't need to know all of the math behind how the light makes the pixels change color. I just want to be like, light on, please. That's it. Now, this kind of approach can definitely have some downsides because obviously like the depth of this API and what you can do with it would end up being potentially limited. But I'm a big fan of just iterating over the API, expanding it if you need that extra functionality. Because that's the thing with code. Like, it's not like, I don't know, a building that you're constructing where you can't just go out and rip out the foundation and make it better in the future. Code is malleable, code is easily changeable, so I like to keep the first iteration usually really simple. Now, just a little side note here, that's not to say that code is always easy to change. Sometimes if you make the core just bad, then you're in for some work. But my point is you're still kind of obviously considering what this is going to be used for and building something that you think will more or less cover everything you need, but you're just kind of more at the simple end of things rather than trying to over-engineer it and then potentially just wasting time and making the end result needlessly complicated, which is just not a good thing. So that's kind of what Walnut Networking is. Now, it uses Valve's Game Networking Sockets API to do all of the actual networking. As I mentioned earlier in this video, I made a video called Networking in C++, which is linked up there. That video covers what Valve's Game Networking Sockets library is. So in this video, we'll specifically just talk about Walnut Networking's API and how it uses Valve's API. So here we kind of see what it is. Again, it's really simple at the moment. Really the meat here, I guess, is client and server. We have these two classes. The premise is just super simple. I would like to start a server on a particular port that is capable of listening to data to that port. Now, in order to actually accept data, we need to establish a client connection first. So of course the server is going to handle that as well. So you can see how it's starting from a simple idea, but then it's expanding a little bit more here. It's gone from just the server can receive data to, okay, the server accepts a client connection, obviously has to manage that client connection, including the eventual disconnection. And then whilst that client is active, it can receive data from that client. And then of course, also send data to that client. And really that's all the server is. Now the client is the thing that connects to a particular server. So it establishes a connection. And then whilst that connection is active, it's capable of both sending data to that server and also receiving data from that server. And that idea already is basically the core kind of layer, which is basically all we need in order to achieve our goal of just simply data transfer between two network nodes. And then we also have these kind of networking utilities, which is just a bunch of utility functions that may be useful for kind of networking related tasks. So let's dive in and take a look at what exactly is in this kind of server header file. And we'll basically just talk about this kind of server and client API. So already I can see something here that I don't like, and that is this. So you can see that we're including this actual Game Networking Sockets API header files within our own header file. And really Walnut Networking is supposed to be kind of like a black box API project. I don't know. Basically what that means is that the implementation details should be hidden. By having these header files inside one of our header files, that means that when we include this header file, which is supposed to be kind of like a publicly accessible header file, meaning if we want to obviously use this server API and start a server using Walnut Networking inside one of our apps, then we obviously have to include this header file, which means we also include Steam's kind of, Game Networking Sockets. I should really just call it GNS or something. It's getting annoying to say. We need to include these GNS, API header files. And what does that mean? That means that these projects, like app server and app client, that include server.h. I mean, really the server is probably the only app including server.h, but if it does, since these also are included, that means that this stuff needs to be in the include path for these projects. I don't want that. I just want us to be able to add Walnut Networking, and that is it. We shouldn't then also have to make sure that these header files are accessible, because that's supposed to be kind of the internal API. It's the exact same concept as Vulkan in Hazel. We don't want the actual game executable project to have to even know what Vulkan is, because Vulkan might not be the rendering API that is used. Why should we have to look up the Vulkan SDK and find the appropriate header files, make sure they're in the kind of compiler include path for our game project? That should all be handled by the actual engine and abstracted away. And so that's why this is bad. Now, how would we fix something like that? Well, it's pretty simple to fix, really, because if you take a look at this, I mean, why is it even included? What are we using inside this header file specifically that needs those header files? And really, as far as I can see, it's just stuff like this SteamNet connection status change callback, which this is a pointer, which means it's really, really easy to just get rid of that. And then we have this HSteamNet connection, which that itself is just a uint32, right? So we have basically an unsigned integer and then a pointer so far, which is obviously very easy to remove. In fact, I'll show you guys how to remove it in a minute. And then we have this HSteamListen socket, which also is a uint32. And then we have this poll group, which is also a uint32. So as an example, how would we get rid of this? Well, let's first get rid of this. I'm going to paste it into the CPP file, because that of course does need to know what these are. What I'm trying to do here, obviously, is not get rid of this entirely. That wouldn't make sense. This wouldn't work without that. I'm just trying to remove it from the header file, because the header file is a thing that is included in other modules and other projects. The implementation file, the CPP file, that is just part of this Walnut Networking static library, and that is the only thing that should actually contain this. So in other words, all the CPP files inside the Walnut networking project are free to include this stuff. It's just the public-facing headers that really should not. And by public facing, I'm just talking about headers that can be included into our actual like users of this API. So the other projects that want to use Walnut networking. And actually, as soon as we do that, we can just hit Control F7 to just try and build this file. We'll get a whole bunch of errors here, obviously, because now none of these, things that we were using actually knows like what type it is. But now we can just simply go back and fix all of this. So HSteam connection, what is that? That's just a uint32t. Now, usually in these cases, I don't even really bother trying to like define this or deal with it. I just fall back to the actual type, right? So HSteam connection is a uint32t, so I can literally just change this to be uint32t. Is this like the safest thing to do? Not really, because if the API ends up either conditionally defining that type, which we know in this case it doesn't, it's always a uint32, but in the future, if it just happens to change it, that might be bad. But otherwise, all it really is doing is we're just kind of taking away the semantics of what that means, right? So HSteam net connection, that's like a bunch of English words that are a little bit more descriptive than just uint32t. And so when we kind of use this over here, we know that this is a map of specifically these kind of connected clients, but you can see we are actually applying our own meaning here. So what I would probably do if I needed to rewrite this code is I'd write something like this, and then I would just be like, originally this in GNS API. So that way we know like what this really is at its core. We can refer to the GNS like documentation if we need to, but we're gonna treat it as client ID because that's kind of what it's being used at. It's this kind of net connection identifier that is just a uint32t. So if we go down here, that means that again, instead of just changing, this to be a uint32t for our connected clients, might as well make it be our type that we define, because client ID makes more sense than uint32t, even though, of course, to the computer, they're completely equal. Okay, so we have this interface, and then we have, let's just do the easy ones first. So we have this kind of listen socket and poll group. Now, listen socket, that's just the socket that we're listening on. Honestly, I don't feel like this needs to be anything other than a uint32t. Like I don't need to make like a using socket, just socket or something, Like it's just gonna be a number between I think 0 and 65535 or something, right? Sockets are limited to 16-bit. Are they? I don't know. Maybe I'll look that up. And then poll group. Now poll group could be a little bit more interesting, but I could do a similar thing here where I just say that this is basically this, but I'm making it a uint32t. And by the way, just to be clear, because this is literally a uint32t, these two types are completely compatible. Because again, they're just kind of fluff that is added onto C++ to make it more human readable. At the end of the day, what is it? It's a 4-byte unsigned integer. That is it. Okay, and then we have something a bit more interesting here. We have this, which is actually a class. However, it's a pointer. Whenever you have something that is a pointer, you have to realize that this part of it, I'm gonna zoom in here, this part of the pointer, yeah, so there's my pointer. This part of it that I have kind of in this red rectangle is completely meaningless. That part has nothing to do with the actual data storage or the type itself. That is, again, purely for you as the human to make it a little bit easier to deal with this type. Remember, what is a pointer? I have a video on pointers in C++, check it out. A pointer is just an integer that contains the memory address of, well, I don't know what, really. It just contains a memory address. It's an integer that is a memory address. It's typically 64 bits because we compile our code in a 64-bit architecture, but it could be 32 bits if you're compiling it with a 32-bit architecture. But these days in 2023, pretty much all the stuff we build here on PC is going to be 64-bit. So therefore, it's just an 8-byte 64-bit integer, and that is it. Doesn't matter if it's an IceTeam networking socket or an int or a void. You can have a void pointer. Does that matter? Absolutely not. It's just an integer, which is the memory address. So then what is this type used for? It helps us be able to use that pointer in a more kind of meaningful and straightforward way. So for example, if it is a type, then by accessing it through an arrow, we can get to either the data members or the functions that are part of that type. If it's an integer, then we know that an integer is 4 bytes. So if I do something like pointer plus plus, it's going to advance 4 bytes forward. If it was a char pointer instead, then pointer plus plus would only advance 1 byte. So it kind of gives this like extra functionality as far as the language goes, as far as C++ goes. To the computer again, doesn't matter. The data type itself is just going to be an integer which holds the memory address. So what does that tell us? That tells us that this again might as well be a void pointer. Now, if we do make this a void pointer though, and we start dealing with this, it means that every time we actually want to use interface for its API, meaning I want to call this function, for example, that is part of this class, we have to cast it to that class. I don't want to do that. So instead what I can do is I can forward declare that type. But that means that I don't know what this type is at this point, but I will later. And to do that, all we have to do is just type in class and then the name like that with a semicolon. So there's no body, there's no definition here. It's just a declaration of that class. Now the compiler will yell at you if you get struct and class mixed up. So usually what I like to do is just actually, go to this class and be like, okay, is it a class? Is it a struct? It's a class. Good. I'm going to use it as a class. Is it part of a namespace? No, not in this case. So therefore it needs to be outside, obviously, of your namespace and just in nowhere. You can also declare it within here, but then you have to make sure that you kind of get rid of any namespaces by just doing something like that. But of course, that's just adding extra code, so I would just pop it over here. So what does that let us do? That lets us actually retain this type. Now, we're not gonna be able to use it. Like if you try to instantiate a class of this type and all you have is a forward declaration, that won't work because of course, how does the compiler know what function to call, what constructor to call, what members to set up and how much memory even to allocate if the type is not defined. So you will have to eventually define it. But again, we're not using it here. We're just declaring it as an actual pointer. So we know already that it has 8 bytes of data storage to hold this pointer within our kind of server class here. And then when we actually start using it somewhere here, like we call new, or in this case, I think we call this function to retrieve that kind of class instance pointer, whatever. By then we need to be able to have the actual definition, which is contained in these headers that we do in fact include. Now, it is worth noting that if this had not been a pointer, this would not work. Because if we have something like this, then what are we doing here? By calling this code like this, we are actually trying to instantiate the class. And it doesn't know what the class is. So that's not gonna work. So this only really works for pointers. Okay, if we come back up here, let's see, well, let's just try and compile this. We'll see what else we're missing here. It's definitely less now. Okay, HSteam.net connection, which is again, our client ID. So let's go ahead and include client ID here, over here as well, which this is set client nick. We've still got H connection. I think that's probably from some of their example code. So we can actually rename this to just be like client ID. And then I'll do the same over here as well, client ID. And that lets us set a connection name here, which is useful for debugging. And then we have these Steam net connection status change callbacks, which is these functions, but again, they're just pointers. So what can we do? We can look at what they are, and you can see they're just structs. So now what I'll do is I'll take this, I'll copy it, and I'm gonna put it over here. So now we have a class and a struct, and that's all we need to do for this. Let's go back to the CVP file, hit Control F7 to compile just that file, and that's it. You can see that our project now built successfully. So what have we done here? We've taken the header files out of this header file, and we've moved it into the CVP file, and everything still functions as you would expect. With the primary benefit being now, app server or app client, our kind of executable projects which use Walnut networking now no longer need that game networking sockets API header files to be in the include path anymore. It doesn't have to know anything about the GNS API whatsoever. It just knows Walnut networking, and that's enough for it. And obviously we'd have to do the same thing like for client, because client does that as well, but I'm not going to do that here in this video. Now, I would also probably just, write a little message here being like forward declarations for GNS API, just so that it's clear, where these even come from, even though, it does say Steam networking sockets literally and Steam net connection change. So you kind of get the point, but I'd still have that there. All right, cool. So we did a little bit of like actual code reviewing here, which is good. If we just take a look at the API, which again, good news is simple, so this shouldn't take too long. All you really have to do here is just instantiate this object with a port. Instantiating it does nothing. So if we're trying to create a server here, we just type in a port like 8192. That's kind of my go-to port number. We then can literally just start the server and we're ready to go. But if we want to be notified of certain events, such as like I want to be able to, be notified if I receive data or a client connects, then we have these functions, which is just simply callback functions that we can just set. And then whenever something happens, that callback function will be called with whatever parameters it needs. Aside from that, we can obviously just send data to a client, whether it be a string or more commonly just a buffer. And a buffer is a walnut buffer, which is just taken from Hazel, a Hazel buffer. It's just a wrapper over like a void pointer, and it's also got its size with a bunch of utility functions that just makes it easier to kind of deal with raw pointers, which are intended to be buffers of memory. We can send it reliable or unreliable, which at the end of the day just basically will call, send a message to connection from that GNS API with either the reliable or unreliable flag. So unreliable might be good for things like I'm making a game and I'd like to, transmit like the player's location, which if I miss a few frames, like that's okay. But reliable might be something like a chat message, or I'm trying to download some data. Obviously I want that no matter what. So if it fails to send it or whatever, resend it. And then what else do we have here? We've got some templated versions here, just so that we can kind of, instead of sending a buffer or a string here, we can just send any templated type. So I could send an int, I could send a struct that is kind of trivial, meaning it doesn't contain like, inaccessible kind of directly data like pointers to other blocks of memory. And then for all of these variants, we also have the to all clients version with an optional client that we'd like to exclude. So this is really useful for that Walnut chat application, for example, because if I receive a message from a client and I need to send it to all the other clients, except for the client that just sent me that message, I can just call one of these functions. And then we can also kick the client. So if we quickly take a look at what it means to actually start this server, once you call server start, it will actually create a new network thread. Then it will kind of initialize the game networking sockets API here. It'll retrieve this like instance of the version essentially of the API we'd like to use, because it might involve Steam, it might not involve Steam, it might be a particular version, whatever. We now have an API that we can use to create like this listen socket IP, meaning we're going to be listening on that port. Create something called a poll group, which just lets us more efficiently kind of handle groups of clients and receive data from all of them, send data to all of them, that kind of stuff. This should definitely be replaced with Walnut's logging, which gives us stuff like, colors and timestamps and logging to files as well as the console. But I don't think that's quite ready yet in Walnut, so I ended up just using cout for now, but that should be replaced. Here's our main kind of running loop. Remember, this is on a separate thread. This is on our networking thread. We'll just poll incoming messages, which, as the name implies, we'll just try and receive messages from that poll group. And then if a message is received, and we validate that we actually have, a registered client sending us that message and we didn't somehow mess up or miss something, then if that message has a size that is not 0, we'll call this data received callback so that, whoever hooks up to that event can actually be notified of the data that we receive, which we then also kind of transform into this Walnut buffer so that it's easier to deal with. We then do this poll connection state changes. This is really, really important. This we'll just call run callbacks, which will basically call this big juicy function called on connection status changed. This is important. It's quite a lot of code as well. This is needed to actually handle the state of connection. So when a client tries to connect, it goes down to this connecting thing, and then we basically have to try and accept the connection. If it fails, we'll do this. We'll try and set a connection poll group for that connection as well. Then we'll retrieve some connection info, which we can use just for debugging really, and just a little bit more information about that connection. We'll register the connected client by just adding it to this map of all of our clients and set its ID to what it needs to be. The ID is obviously important if we want to both kind of manage that connection, but also send data specifically to that client. We need the client ID, so we store that. And then we'll call the client connected callback with, this probably should be set though, as in we probably should test that to make sure that it's not just null, because this obviously is just an std function, and that can kind of be null, which I think in the current version of the library at least means that it will probably crash or something. So I think that's just an oversight. It needs to be behind an if, I believe. This code review is already paying off. And that's kind of it. Now, if we disconnect or whatever, that happens here. If it's closed by peer, meaning the client wants to disconnect and it is currently connected, then we can obviously call the client disconnected callback, remove it from our client list, do all of that kind of stuff, and then just close the connection kind of cleanly. So that's really all the server does. It's simple, but you can see that still, this is almost 300 lines of code. There's quite a lot abstracted by this. You can see how much code is needed from the actual GNS API that I didn't want to write. Didn't want to, poll incoming messages, start a thread, do all of that stuff if I wanted a simple server. That's what Walnut networking is for. So if I look at the actual app server project, and we go to where we create the server, which is over here, you can see that this has a Walnut server over here. Here's our Walnut server. And then what do? We just create it with a given port. We just set our kind of callback functions here to call into member functions inside this class. And then we just start the server, and that's all we have to do. And then, like, for example, if we receive data, well, let's see what that looks like. This function will just simply be called by the Walnut server class with the client info of who sent it and a Walnut buffer, which contains like the buffer of data that we receive. And then we can just deal with that. Like, it's super, super simple, super straightforward. Now, the client API is also really simple. If we just cut to the actual app client and we take a look, you can see, again, we just create a client. We just set up these callbacks, which do the same kind of thing as the server. And then it's not quite as simple as doing client.start, because obviously we need to connect to a server, and we have that kind of UI, modal dialog that lets us actually type in a server address. So after that address is like, typed in and we want to connect to it, we'll basically call client connect to server with that server IP. And then that, internally we'll basically start that network thread, which will try and connect, by IP address to that server after parsing it, making sure it's valid and all of that kind of stuff. So you can see that does also kind of abstract quite a bit, and it makes it really simple. Again, the kind of Walnut client API here is just create the client class instance, set your callbacks, and then just type in an IP address that you'd like to connect to. Now, before we do that though, you can see that we have some network utility functions, which is this kind of other class that I didn't really talk about much yet. These are just some utilities. There's basically two here. There's just isValidIPAddress, which will actually call the Steam networking utility function that will check to make sure that we can actually parse this string into a valid IP address. Meaning have you just typed in like this, or is it like properly kind of formatted, to be something like this, which is valid. This I think includes IPv6 addresses as well. And then we have resolve domain name, because Valve's Game Networking Sockets API does not contain any kind of way to actually connect to a domain name and resolve it into an IP address. It only lets you connect to an IP address. So we have to basically write our own function here, which in this case uses just the Win32 API, and therefore we have a different implementation depending on the platform. So for Windows, you can see this is actually tucked away into Walnut Networking Platform, Windows, Walnut Networking, and Windows Networking utils, so that we only compile this on Windows, not on Linux, which we also support, because of course this is just Win32 API stuff, won't work on Linux. And then this is just, you can see I've written a note here that's adapted from this example inside MSDN. And then, yeah, this is what it does. Basically, it just takes in a string view name, such as chat.thecherno.com, and it will hopefully give you out an IP address, either like an IPv4 or an IPv6 address, which you can then take. You can see we do a little resolve domain name here. We'll separate out the port as well as adding a default port if we didn't specify a port, and then we'll connect to that server IP, which expects to basically have an IP address and a port in that kind of format that I typed out earlier. Okay, well, there's lots more really to talk about. That's like the basics, I guess, of Walnut networking. Yeah, the client, I didn't really go as thoroughly through the client as I did through the server, but it's very, very similar. There's still that same on connection status change, except it's obviously a bit different because we're the client, not the server, but we still need to make sure that we can actually successfully maintain that connection. What happens if the server shuts down? We should probably be notified that the server's gone. And you can see that there's additionally this thing called a connection status, which is disconnected, connected, connecting, failed to connect. And the reason why this exists is because typically we're disconnected, meaning that we have either just made the client instance and we haven't connected yet, or we've specifically cleanly disconnected, versus are we fully connected and active, or are we in the process of waiting for a connection, like we've requested a connection but the server hasn't finished that kind of handshake to establish the connection, or have we tried but we failed? And this is really nice because we do run this kind of asynchronously, I guess, on a special network thread for the client as well. But if we are trying to render some UI that is what is going on, then we can just simply query from any thread what the connection status is, just kind of read only here. And if it is connecting, we can be we're currently connecting. Or if we failed, we can be you failed to connect. So there's just a little bit more kind of status here. And that's kind of a useful thing that this API also provides. All right, I think this video is dragging on long enough. There's still so much more that I want to cover. I want to cover this whole kind of headless configuration as well and how that fits together, as well as the actual app client, app server. I didn't cover that at all. So let me know if you want to see more in the comment section below. Hope you enjoyed this video. If you did, please don't forget to hit the like button. As always, don't forget to check out brilliant.org/thecherno, and I will see you guys next time. Goodbye.